In this lesson, we'll talk about order of operations, part 2. We already know some operations. We know the operation addition, 6 plus 2 equals 8. Multiplication, 6 times 2 is 12. Subtraction, 6 minus 2 is 4. And division, 6 divided by 2 is 3. So all an operation is an action that takes input values and produces output values. Every operation has an inverse operation. For example, the inverse of addition is subtraction. Here's what I mean by inverse. If you start with the number 5, you add 4, you get 9. Take that answer, do the inverse subtraction, 9 minus 4, and you get what you started with, 5. The inverse of multiplication is division. For example, 8 times 3 equals 24. 24 divided by 3 equals 8. Our last operation is the squared operation with the inverse square root. For example, 6 squared equals 36. The square root of 36 equals 6. So far, we've talked about the order of operations. Our first operation is exponents, then multiplication and division from left to right, then addition and subtraction from left to right. Notice that these groupings are inverse operations. What I mean by that is addition and subtraction are inverses, multiplication and division are inverses, and in the last slide we learned that exponents and roots are inverses. So our full order of operations is exponents and roots from left to right, then multiplication and division from left to right, and finally addition and subtraction from left to right. I want you to give it a try. Try this problem on the bottom. Did you get 33? If not, go back and check your work. If so, try this next problem also. And the answer should be 15. The last agreement is agreement number 5. We can build fences to change the normal order of operations, evaluate inside any grouping symbols first. For example, I have this expression, and if I use the order of operations that we've learned so far, I get the answer 3. But what you can also do in mathematics is use grouping symbols. And remember, these grouping symbols we have to do first. So for example, if I wanted to simplify this problem, first I would do inside the first grouping symbol, 11 minus 5 is 6. Then I would do inside the second grouping symbol, 32 divided by 4 is 8. Then I follow the order of operations. 8 squared is 64, 6 times 2 is 12, and 12 plus 64 is 76. These grouping symbols are called parentheses. But there's more grouping symbols than just parentheses. The next one is brackets, square root, and fraction bar. All of these are considered grouping symbols, and they act just like parentheses in the first problem. So let's do this problem together. I see that there are brackets, so I know I have to do what's inside the brackets first. 3 squared is 9. 9 minus 3 is 6. 42 divided by 6 is 7. Try this problem on your own. And the answer should be -4. Try this fraction bar problem. The answer is 2. We can put fences inside other fences. Start with the innermost fence and work your way out. In this case, we have 2 sets of fences, so we start with the innermost. 17 minus 2 times 5, order of operations, 2 times 5 is 10, 17 minus 10 is 7. Then we move out to the next grouping symbol. 7 times 3 is 21, 21 plus 2 is 23. Multiplication, 5 times 6 is 30, so 23 minus 30 gives us our answer, -7. To help us remember the order of operations, we came up with an acronym called GERMDAS. The G stands for grouping symbols first. Next, we do exponents and roots. Next, we do multiplication and division. And last, we do addition and subtraction.